let's go ahead and get started with today's webinar.
For today's webinar, we are going to continue on in our impromptu, two-part series with this part that we have here, an automotive example where we reverse engineered a sheet metal part yesterday, and then today we are going to cover this part here, focusing primarily on the tubes and the catalytic converter assembly there that we see with sensors and everything like that. So let's just toggle over to our next slide here. So just as a recap for anyone that was not on the webinar last week, we started with this model here on the top left. The blue object there is a 3D object. And you notice I did not say scan in this instance because this one didn't come from scan data. If I remind everybody here of what we talked about, that this one was an example of taking a polygon object, a mesh file that comes from CAD, because some of the products in the industry, there is, honestly, there's some controversy out in the industry about the right to repair in certain industries, like the industrial farming industry with tractor manufacturers and making parts and designs that only the OEM, and designing them in a way that only the OEM can work on them, right? And depending on where you are in our country or the world, your local laws may have what we call, at least in my area, as right to repair. So some states or countries may have those rules that make it so you have to be allowed to fix the equipment that you purchased from an OEM. And in this instance, this happens in the aerospace and a few different industries as well. They'll go ahead and give models, but they're mesh models. Like they'll export them in a way that it strips everything off of the model, and you're stuck with this low resolution mesh that is the assembly, and they're basically saying, here, have at it, fix it if you want to, or create your own designs from there in this instance. So in this instance here, that's what, not that this was a right to repair scenario, I'm just saying that that is a scenario that exists where OEMs just save out mesh files and just give it to people, and they're allowed to then reverse engineer it. And this isn't coming from scan data in this instance, although you could do that. We're just highlighting it here that sometimes you reverse engineer CAD meshes. So my super long-winded explanation here is this is reverse engineering CAD meshes that are saved out that don't always come from scan data. So you see here we have the final product where we reverse engineered the entire assembly, and it was done in 3 phases, where it was the sheet metal backing plate there, which we covered last week, and then this week I'm going to go over the piping and then the assembly for the catalytic converter. So with that, let's go ahead and jump over to our next slide before we dive into DesignX. As usual, before we get started with our DesignX portion of our webinar, I always like to bring up this slide. I know for some people that watch weekly, this slide can get a little redundant, but we just wanted to make sure that everyone that jumps on the webinar understands the workflow and where DesignX fits in here. So as you can see here on the left-hand side, we have different types of 3D scanners, and DesignX has the ability to connect to those scanners with plugins and import tools, and we have done it for over 30 years, so we have every kind of importer, file type, plugin imaginable to connect to these different types of 3D scanners. And then DesignX is really a CAD platform that utilizes our own scan kernel that we have built from the ground up internally, that allows us to handle all that scan data as native entities, bring that in, process it in a way that we can extract model information from it, whether it's CAD model information. Sometimes people want to go straight over to additive, as you can see on the right-hand side. But many times people want to extract CAD model information, both design intent or as built, and send that over to CAD. So by far the top section there is the number one output, where we have a live transfer tool that will allow you to transfer over the CAD information as native entities over to these different CAD platforms. The second one down is we can then save out models like step, IGESat, neutral, all these different native interchange formats to send over straight to CNC packages for cutting stuff directly, or additive. Some additive packages will take CAD models or meshes, and we can save out to those as well. But that's what DesignX's overall workflow is to handle that heavy lifting of grabbing scan data, bringing it in, processing it, extracting just the CAD information or 3D model information that you need, and sending it out to the proper output. Now, there's a whole other host of things that you could probably do. These are just the highlights of the different applications that we send out to on a routine basis. So with that, we'll go ahead and jump over to DesignX for our presentation. So here is the scan data for the final, we'll just turn off the scan data there, for the final model of the catalytic converter. And you'll see that we got a few things here. We got like brackets that we've modeled, and the O2 sensor, and a heat shield, all kinds of stuff. So let's go ahead and jump in, because I do think this will probably take a minute. So let's roll back and show just the scan data. So here is the scan, and we will roll forward and see which approach they took. So the first thing that they did is they went ahead and did a sweep on this data here. And honestly, most of the time that we do these sweeps so quick where it's a 3D sketch, if you see a 3D sketch and it's all self-contained like that, almost 100% of the time it is us using our sweep wizard or the pipe wizard, which is right in here. The pipe wizard, let's go ahead and turn the surface off and turn the regions on, where you can grab this region and hit next. And this tool is just so cool how fast it works. You see there, it goes and it creates a center line and draws it as a spline and then a profile and then gives you the preview. And you can tell it like, hey, calculate this as a line arc instead of a spline. And I'm just going to do that with mine. And you can even override and say, hey, this has to be a 9mm pipe radius, and then hit OK. So I just made it. I think mine is better, actually. Right here. See that? We just created one with a line arc. And there you go. We created that solid body now. I'm going to go ahead and get rid of that just so I don't do something that changes the history. We don't want to rewrite history here. So we'll go ahead and just go forward. But that is what the point I wanted to make, is that this pipe wizard is so fast, and most of the time when you see those in the tree, that's what it came from, is doing that. So let's just go ahead and jump forward here. Now the next step is we went ahead and created a surface revolve. And you see here, if we hide the proper thing here, hide the mesh, there's our revolve. And depending on the position of the plane, that plane position is very well positioned, so it was probably a manual creation. But I look at that because if the plane is in a different orientation, then that they could have used a revolution wizard to create that one too. Now we'll go ahead, and they went ahead and did another sweep over here. So you see here what we're dealing with now, and now we're going to go ahead and connect it all together. So they added a surface torus to the end of that, which is really just a revolve. That's just the name. And the fact that it says surface torus means that it could either come from this right here, which is probably what happened. They created it using surface primitive. Surface primitives, you can do surface or solid primitives and just tell it to create a tori around that. And based on the naming, that's almost 100% what they did, right? So now we'll go ahead and roll forward a couple more. And you see that they went ahead and trimmed those two together. And now we're going to jump into, here they did a loft wizard. So a surface loft, sorry, not a loft wizard. What they did, almost definitely they did an offset plane from here, right there. They did an offset plane there. They just drew two circle sketches right here and then lofted those together to create this shape. And since we're dealing with very precise models, that's the difference between this model here being a converted CAD model. It's very precise. So we're able to fit stuff super easy because there's next to no error. It's maybe like tessellation error in there. Now from there, they're going to go ahead and let's just turn that off so we can see it. They went ahead and did a surface extrude from the edge up inside of the torus, and then surface extend on the other side. And now we're going to trim it all together. So that was a neat way of doing it because this is a slightly different angle. This happens in automotive. This is part of the reason why scanning is so efficient here. Is this is a crazy angle of some sort coming from here to there, and you could just loft that together and then come back now and add your fillets, and there we go. We have the connection. Now they go ahead and do that on, I believe, on the other side as well. So on the other side, let's just turn the mesh on so we can see what we're dealing with. First of all, they have a flange that we model in order to so we'll just turn the mesh on and off. There we go. A flange adapter where they're going to mate those together. And then we go ahead and cap that all off and merge it all together here. So it looks like they just did a surface right there on the end, capped it off and made it a solid. And let's get going. And then the same technique we did before, where we did a surface loft on this. Extend. And we'll just hide the mesh so you can see what we're dealing with. And they created a face there. Trim it all together and merge it all. There we go with our fillets, and we're knocking this out pretty quick here. Let's just turn that mesh back on, and you see that there is a heat shield around the outside as well. So we'll just see what direction they go next. Okay, so we went ahead and filleted that with the extrude, and same thing on the other side. Basically, that's just like the trying to think, the stamped out bead that's around where they kind of swage it on there. Okay, so now we are going to go ahead and revolve the heat shield, do a surface loft about that, do a surface extrude and trim it all together. There we go there, fillet that, really neat. Then we're going to go ahead and trim it in half. We'll just turn on the mesh so we can see. You see what they did is trim it in half, and then now we're obviously going to do, they go ahead and do the thicken first, and then we'll probably trim that thicken next. Yep, from that direction. So now we've created the heat shield there. And then now let's see these next this next batch of, okay, so we did a bunch of cuts, and so you see here they're cutting. Somebody must have asked to do that, because I don't think that's part of it. I think that might be part of how it was like exported. And now jump forward there. Anyway, chamfer here. Those swaged on fasteners. Just modeling the rest representations of these fasteners here. And more fastener. There we go. So far so good. Now looks like we have another sweep here. So let's see where that comes from. All right, so now this is the O2 sensor on the other side here. So if we turn that mesh on and off, and it's the same tool here. This, if I look at, that's basically a sensor's cable. In that instance, don't bother doing the Pipe Wizard. Pipe Wizard is made for constant bend radii and constant, obviously constant profile. So you definitely would use the Sweep Wizard on this one and just select that as all one. And you see here, that's what they did and created that. So it literally only takes a second to create for that sort of thing. And now we'll just jump forward here. Just did the revolve for the O2 sensor. Just your basic cleanup stuff for that. Modeling the hex for it too. And let's see what this next sweep is, because that's another major thing. Oh, they swept the bead around the outside, which I believe that's a welded bead on that, where they welded that adapter, so this O2 sensor can screw in. So let's jump forward a few different steps here, and let's see what we got. Okay, so now we're doing the heat shield on the other side. So you see that we went ahead and let's just, they did an offset, and then they're going to cut and trim that and then fillet that. And we'll just hide the solid, hide the mesh. Turn the mesh back on there. So there you see what we've created. And then trim all that together. And there we go. And I believe there will be a thickening coming up. Let's see here. Oh, they went ahead and did these strips as well. So kind of like building out all kinds of other things. They then add the fillets to it too. Then We'll do the thicken. And so that makes it a solid. And there we go. Heat shield created. Another one. Another one down. So now we have the bracketry that we will get to here. So what they did is they went ahead and roughed in all of the fitting all the shapes, whether it's an extrusion wizard here, a pipe wizard, a surface fit, and trim it all together. And we'll see here. Now then they're going to fillet the interior boundaries of all this. Oh yeah, that trim tool. They're going to fillet that. Rough out the edges now. So we'll take a look at it right before it's thickened. Turn off the mesh. They basically just create the zero thickness surface, then come in and thicken it out. And now let's fast forward here. Add all of the fillets there. Let's see what these surface offsets and extends are all about. Okay, yeah, because there was some extra pieces here. So let's turn the solid off. There are these extra either welded on pieces. So they went ahead and modeled those and then merge them in. Then your cleanup stuff. Look at that. Oh yeah, now for this, we'll just locate where that is here. Yeah, it looks like they designed it in a couple pieces instead of doing it as a sweep. Right? They designed this right here. Let's just roll right back because I'm just curious. Yep. Okay, so they just did a surface offset for that piece that they drew, and then went ahead and filleted it all. Boom. So when you first see it, you're like, hey, I could do a sweep, but that must have been faster for him to do, just drawing that out versus going the other direction with it. Those are the reasons why we do this webinar, by the way, is you see how many different ways there are to model in here. It is just crazy. And the only way to really get better is just pure experience of seeing problems and coming up with solutions. And you end up developing a plethora of solutions to your modeling problems here, and you kind of have a toolbox of different methods in the past that you've used to figure out how to model these complicated shapes, right? And okay, so they went ahead and created this and merged it, and we just created all these as a stand here. But you basically have this toolbox of things that of different techniques on how to model stuff and how to reorder things, and it's just like an experience thing is the only way to gather it, right? Is knowing how to use this tool is one thing, but then also knowing how to model is a separate thing. And so I'm doing both things when we do these webinars, where we're looking at how to reverse engineer it with the tool set that's available here in DesignX. But we're also learning techniques on how to model things. Now, it just so happens that reverse engineering is a slightly different type of process, and putting it all together into one skill set here. So let's see where this is. I believe this is the bracket next. Yep. So we're gonna, you see there, fit that, fit this, trimmer, trim it together. And you see we did another sweep for that cable. That was a cable pull. Looks like maybe emergency brake. Maybe, I don't want to speak. Could be. Looks like a cable. And so we trim that all together. And let's just jump forward a little more. And we did that again. We're adding that rib to the bracket. Fill it all, solidify all of it. Over there. And that's what it was. That's where it was. So we went ahead. This is a really quick one, the hanger, the exhaust hangers. So it's just an extrudes all of these things, fits. And we'll just jump forward there. And then, yeah, now we're just going. This is a method for 3D sketching, by the way. So watch what happens here. We're going to trim all these together. You see here that from this direction and that direction, we are going to draw these surfaces and trim them. Now, just like that. So we'll get out of that and we will turn that surface on. So we now turn off the mesh. We basically did that as a way of 3D sketching. So we created the sketch from one direction, the sketch from another. Now we come in, we draw a 2D sketch that pierces this edge here. And now if we come into this surface profile, let's just get out of that. Let's edit the sweep. I have to step back forward again. So now we created the sweep. Now let's edit the sweep. You see what we did with the edit of the sweep. We selected the path for the sweep is the edge that was created by these surfaces. So this is what I would call like an old school way of doing 3D sketching, where you draw these surfaces and trim them together and use the edge of that surface as your 3D sketch for something. So now, and they basically did that sweep in two different segments. They did that from the other side. I'm not sure why, because it is all the same, right? But that right there is the tip of the day. Just to highlight this, just so you know, like that is a really valuable tool for your toolbox when modeling here. Is sometimes line art 3D sketching is very difficult to kind of break down and create stuff, but you can actually trim surfaces together to create that, and that's how we did it here, and it was very effective. So now we'll just apply a fillet to that. Where is this loft coming from? Okay, lofting in between the two. That's a interesting way of doing it. That's different than what I would have thought. Now, all these little ancillary pieces. Cutting some areas away, which I don't believe even need to be cut away. And now we move back over to this and finish it out. So there we go. Modeled the fasteners for that too. And then we'll hide the surfaces. So here is our final result. And based on the time today, we'll go ahead and cover the last one next week, where we cover the pipes from the other side, because it's going to be a little while longer. But I feel like this was just a really good use case of showing the loft sweep wizard, looking at how they created these heat shields and trimming them together using offsets and surface trimming it together. And then my favorite thing from this one is just showing how you can use surfaces for 3D sketches on this. And yeah, hopefully this was valuable for you. And thank you for your time. And we will jump back over to our PowerPoint for Charlie to take us out.